Hey everyone, so today we are going to talk about something called the Factor Theorem. So this involves factoring polynomials. So start with this do now. Pause the video, do it on your own. Alright, so remember the first thing you should do is count how many terms there are. In this case we have 3. And I noticed that the middle term exponent is half the leading term. So that means it's just a regular multiply and combine. We're multiplying to negative 27 and combining to 26. So 27 and 1, where my 1 is negative, to give me a positive 26. So instead of x and x cubed times x cubed is x to the 6th. And then plus 27 minus 1. And remember, when we're factoring polynomials, we need to check, can I do this again? And in this case, I can. These are both perfect cubes. So we're going to use our perfect cube formula. So this 27 is 3 to the 3rd, and then 1 is 1 to the 3rd. So I've got x plus 3, x squared minus 3x plus 9. And then x minus 1, x squared plus x plus 1. So I'm using the formula a cubed plus b cubed. It's a plus b, a squared minus ab plus b squared. And then you just switch the signs for the minus. You switch the plus here and the minus here. All right, and then this one, we've got 1, 2, 3, 4, 5, 6. So when I have 6 terms, I'm going to check for 3, the first 3. And that is a perfect square binomial, right? If you have trouble with that, one thing you can do is rewrite it without the y, right? Look up top here. If I write that as 8x squared plus 8x plus 16. So I just took the y squared and the y out. That's a little easier in our head to factor, right? What multiplies to 16 combines to 8, x plus 4 times x plus 4. So x plus 4 squared. But we did have that y in there, so the y is going to go with the 4. So now I'm going to look at the rest of this. The next two do factor. I can factor out a 3, and I'm left with x plus 4y, and then minus 40. So this is in the form of a multiply combine again, right? Think of this as a squared plus 3a minus 40. So what multiplies to negative 40 combines to 3, 8 and 5. Right? So plus 8 minus 5. But instead of a, what do we have here? We've got that x plus 4y. So x plus 4y plus 8, x plus 4y minus 5. And that is our answer. Okay, x to the 5th minus 32. If I gave this to you and said factor, what would you do? Well, it's not the difference of two perfect squares. It's not perfect cubes. It is perfect fifths, though. So x to the 5th minus 2 to the 5th. So what would you do? Do you have any method you could do? Well, since it's 2 to the 5th, my guess is this thing, x minus 2, will go into that. So you can either use synthetic division or long division to figure out the rest of it. So I'm going to use synthetic. So since it's minus 2, I'm going to put a 2 on the outside. X to the 5th, and then the 4 is missing. 3, 2, 1, and then negative 32. So 1, 2, 2, 4, 4, 8, 8, 16, 16, 32, 0. So that's going to be my polynomial. So I started with x to the 5th, now I'm going down to x to the 4th. 2x to the 3rd plus 4x squared plus 8x plus 16. Now, does anything go into that? I honestly am not sure. We're going to stop, though. So when you don't know how to factor it, we use synthetic division for guess and check. So that's basically what this lesson is going to be. All right, so the factor theorem states that x minus a is a factor of a polynomial if and only if p of a equals 0. So if we have a polynomial and we plug in a number, so if I have some polynomial p of x equals, I don't know, x to the third minus 2x plus 5 or whatever, and I plug in an a and I get 0, that means I can factor this with a bunch of stuff, right? So if I plug in and I get 0, so it goes in nicely, then that x minus a is going to be a factor. It's factor theorem. And now here's the important part. The integral zero theorem. The integral is another word for integer, so it's just another way of saying integer. So if x minus a is a factor with an integer coefficient, then a is a factor of the constant term of p of x. All right, so now, I know that sounds weird. What this is saying is, I'm just making this polynomial up. P of x equals, so a constant term. What's the constant term of this polynomial? 5. So this theorem is saying that all the factors of the polynomial will be a factor of 5. So the only thing that could possibly divide into that is x plus 1, x minus 1, x plus 5, or x minus 5. Those are the only possibilities. So you look at the constant term and write down what are all the factors of it, and those are the things you have to check. So we don't have to check x minus 7, x plus 3. We only need to check the ones that will go into 5. Okay, so number 2. Again, we're going to be using synthetic division to guess and check. So the first thing we're going to do is write down what are all the things that multiply to 6, divide into 6. So we have 1, we have 2, we have 3, and we have 6. But here's the thing, plus or minus, plus or minus, plus or minus, plus or minus. So we have up to 8 things that we can check, right? It's not going to take us 8 times, I promise. So I'm going to do synthetic division. Now grab a pencil or scrap paper, whichever you prefer. If we were in school, I would give you one of the whiteboards to make it easier. So with synthetic division, I'm going to write down all my coefficients. And, before we start, one thing you want to check, can you factor it? And this does not factor by grouping. It doesn't work. Okay, so I always start with 1, and I kind of just work my way through. So I'm going to put a 1 outside. So 1 times 1 is 1. 3, -2. Okay, so this is not going to work because I have a remainder, right? The whole goal with this is to find something that goes in nicely. So now I'm going to erase. All right, so bring that 1 down. So now I'm going to switch the sign to -1. So I tried 1, now I'm trying -1. Let's see, -1, 1, -1, -6, 6, 0. So this one worked. So that means this function, since that's a minus, remember we have to switch the sign, is x plus 1, and then what are we left over with? X squared plus x minus 6. But now look at the answer. Look at this trinomial. Is that factorable? It is. X plus 1 times what multiplies to -6 combines to 1, 2 and 3, where the 2 is negative. So now you could keep doing guess and check if you want. You would eventually get, you would eventually get the other 2. Now, do you have to go in order? No, I just like to do that to keep track. All right, so now that you've seen number 2, pause the video and try number 3. So I'm going to go through, and I'm going to start with my multiples of 8 are 1, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All right, so I got 1, negative 7, 14, and negative 8. Start with my 1, see what happens. Negative 6, first try. I honestly didn't even look up the answer. First try and it worked. So x, again, change the sign of that, minus 1. And then I get x squared minus 6x plus 8. So then I'm going to try my MC chart. Multiply to 8, combine to negative 6. That's x minus 2, x minus 4. Now, if you skipped 1, let me erase. Let's say we had 2. Let's say I did a 2 instead, because 2 does work, right? Let's say I did this instead. So 2, negative 5, negative 10, 4, 8, 0. In this case, I would get x minus 2, and then x squared minus 5x plus 4, and then I factor that guy, and I get x minus 2, x minus 1, x minus 4, which is the same answer, they're just in a different order. So if your process is slightly different, that's okay. Don't freak out. All right, pause the video and try these two. Same process. All right, so I've got 2, negative 5, negative 4, and 3. All right, 1. So I multiply, I get a 2. Bring that down, negative 3, negative 3, negative 7. That's definitely not going to work. I'm not even going to finish the problem. All right, let's make that 1 negative. So negative 2, negative 7, 7, 3, negative 3, 0. So that one did work. So now I have x plus 1. Don't forget to change the sign. And then 2x squared minus 7x plus 3. Now this one does factor. So think back, how do you factor when there's a number in front of x squared? So 2x and x. I'm going to do this one in my head because the numbers are small. 2 times 3 is 6, plus 1 is 7. So you could have, so now notice, this is a 3, but then because there was a 2 in front, one of the factors was actually a half. Because the 2 was in the front, we're going to talk a little bit more about that tomorrow. But if there's a number in front of the leading power, that throws in some fractions for us. All right. And then this one, we got 1, negative 4, negative 11, and 30. All right, I'm gonna guess I bet it's a 1, a 5, and a 6. That's my guess. Let's see if I'm right. Negative 3, nope. Negative 1. Let's see, negative 1, negative 5, 5, negative, nope. All right, I'm going to try 5. I just, in my heart of hearts, I feel like it's going to be 5. Watch me be wrong. 5, 1, 5. Oh, I'm so smart. 0. 5 worked. So x minus 5. And then I'm left with x squared plus x minus 6. So I'm going to factor that, and I get x, multiply to 6, negative 6 combined to positive 1, so plus 3 minus 2. So I knew there is a 6, sort of. 3 and 2 is 6. All right, last 2. These are a little trickier, though. So notice what's the highest power this time? A 4. So we're actually going to end up doing synthetic division twice. So you're going to have to do synthetic division, and then synthetic division again. Because most of the x cubes are not going to be nice factorable like we've been doing. So pause and try number 6. So I've got 1, -5, 2, 20, and -24. And 24 has a lot of factors, but again, I always just start with 1 and hope for the best. -4, -2, 18, so that doesn't work. Erase these. So now I'm going to try -1, -1, -6, 6, 8, -8, 12. Nope, that didn't work. So no 1 in the problem. Let's try 2. -3, -6, -4, -8, 12, 24. Oh, got it. So the first one is x minus 2. But now I have to keep going, right? Because I have an x cubed. Actually, that's actually factorable. I'll show you in a second. Let's just keep doing the synthetic division. Let's try -2 this time. -2, -5, 10, 6, -12, 0. So I get x plus 2, and then x squared minus 5x plus 6, x minus 2, x plus 2, and then that becomes multiply to 6 combined to -5. So this one is actually, if you simplify it, x minus 2 quantity squared, x plus 2, x minus 3. If you look at this, what we got here, that's x cubed minus 3x squared minus 4x plus 12? Yeah, that's a factor by grouping. You could do x squared, x minus 3, minus 4, x minus 3. So that one was actually factorable. That only happens if you have a dots in the problem, a difference of 2 perfect squares. Notice in this case we have that x squared minus 4. All right, last one. Try it on your own. 1, 5, -6, -20, and 8. Let's see. 1, 1, 6, 6, 0, 0. No. I know I could just like jump ahead. You guys can skip ahead if you want to just check the answer. But I like to show my work, show that I'm not going to get it right away. -4, -10, 10, nope. Just to show that I do sit here and do these out, like before the lesson even starts. This is definitely one of those lessons where I have to go through and do all the work before I teach it. All right, so you got 2, 7, 14, 8, 16, -4, -8. Got it. So that's an x minus 2. And I'm going to do it again. And I always just do this. I kind of just do it right under it. All right. So let's try -2 this time. -2, 5, -10, -2, 4, 0. Ooh, I got it. I literally was just guessing too. X squared plus 5x minus 2. Now we're actually done. That is not factorable. If you look, x squared plus 5x minus 2, you can't factor that. So we're finished. All right, practice. This is not difficult, it's tedious, right? It's just synthetic division over and over and over again until you figure out the answer. So, all right, have a fabulous day.